Hi everyone, my name is Laurent Ploix, and it is a great honor for me to give you that presentation today. For over 20 years, I've been interested in the topic of development productivity. I've looked into continuous integration, continuous deployment, the lean methodology, and so on and so forth. But it's only been a few years since we started to use data science properly to understand and look into the data we produce internally in companies and connect the dots with development productivity. So today, we will look into improving development productivity at scale. More specifically, we're going to look into the lessons and the insights from implementing it at Spotify. Let's look into it together. There will be 5 parts in our presentation. The first one is going to be quite short. It's about the context in which we are today and why this is a good time for DP. The second one, quite important. We need to speak the same language, we need to understand each other, and the mental frameworks are here to help. The third one, probably the most important part, the use cases, the mistakes we made, the lesson we learned. Then I will explain the methodology and look into the risks and threat to validity. So, what is the context of development productivity engineering? Let's look into 3 major aspects of it. First, let's look into the differences there are between software development and the other functions in a company and why that creates some frustration. Imagine for a second you are in human resources. You need to hire another 200 engineers in the coming 6 months. That means you know exactly the number of engineers you should be hiring per week on average. And maybe it goes according to plan, but maybe it doesn't. So if it doesn't, you can have a conversation with your CEO and identify that maybe you don't get enough good CVs, or maybe we don't spend enough time interviewing candidates. You can find corrective actions for that, such as finding more time for candidates, for instance, or doing a better job at advertising the positions. In any case, that's relatively easy to identify how much that's going to cost and the expected return on investment and how that's going to correct the problem. Now you are in software development. There is the current situation where you're in, all the features you have in your product, how they're used by the customers and so on, the level of quality, maybe the level of tech debt that you need to deal with. And then there is a target situation. All the iterations you need to go through to release new features. Maybe also you want to reduce the level of tech debt. The first question you have is, are things going according to plan? It's famously hard to understand how fast you're going at developing software and if you're actually decreasing technical debt or increasing it, and if the features are actually ready to be released or not. So that creates a frustration because the first thing is you cannot really have a conversation with your CEO and say, okay, things are going according to plan, because you don't actually know that. It's also famously hard to predict how long that's going to take to implement something. So when you have this conversation, you're like, okay, I actually don't know precisely if things go as planned. And I actually don't know for sure about the corrective measures, maybe except for just hiring more people, but to do what exactly? The return on investment on the people you hire is really difficult to evaluate. That's the first part, which is quite frustrating for the higher management, and we want to have a much deeper understanding of it. The second aspect is the economical context. For many years, roughly until 2022, financing debt was kind of free. So the companies focused on market share and growth, generally speaking. But things have changed. Today, debt is quite costly. As a consequence, people or companies focus on ROI, return on investment. The investment part, we know what it is. That's the cost of running the company, the cost of hiring people. But the return part, as I said, is quite hard, quite difficult to evaluate, especially in software development. DPE will help us evaluating that value. The third aspect is data science and how that can be applied internally these days. First, I would like to look into statistics and modelization. For quite a long time now, the industry has learned how to do A/B testing properly, causality inference, the idea being to know, okay, if we make that change on the product, the impact on the market is going to be that much. For instance, we want to understand if people are more engaged when we make a change in the UI. Those aspects, this data science, can be applied internally because we got enough data for it, and we can use A/B testing, causality inference on internal data. The second thing has to do with alignment. Across all the industry, we have all started to adopt some DORA metrics, for instance, and metrics with some dimensional space. As you probably know, DORA metrics are typically implementation of space. We also see well-designed internal surveys that we can pick from other companies and start to apply internally. Consequently, this alignment has helped companies talk to each other and share success stories. Then, in LinkedIn, Microsoft, Google, Spotify, and others, we start seeing internally facing insights team, meaning teams that consider their own company as the object of study. That helps a lot because these teams will know very well how the company works, and they will be able to apply the statistical methods that I was talking about. And last but not least, some good tooling has been published recently. I'm talking about dbt and then databases of the same kind of BigQuery and others. This also helps a lot because now we don't have to reinvent the wheel every time we want to implement data extraction, computing metrics, or extracting insight from that. So to recap about the context we are in, people are frustrated and they want to know more about the value that gets created by software development. There is some pressure from economical context, and we have some tooling and some alignment and data science we can apply to it. That's why this is a favorable context for DP. Now that we have looked into the context, let's look into the mental frameworks that we need to understand development productivity engineering. Have you ever wondered if we mean the same thing by productivity, and what are the different types of productivity in the companies? Let's look into some of them. So if we discuss with management or product leads, productivity typically means bringing value to customers, but of course the right product, the one people are expecting. And of course it needs to be delivered quickly, obvious. If you talk to the team leads, they will tell you that they need clear and stable strategic direction from product. That means that they shouldn't have to switch project or switch direction every month or every second month. Secondly, they shouldn't wait for other teams to implement something. So if you have an organization where one team depends on another one and they have to wait, then that's wasted time. Last but not least, you have internal collaboration between the team members. An efficient team, a team that produces a lot of good code or a lot of good value, will have team members that can collaborate effectively. Now, if you talk to people, that's going to be a little bit different. Developers need strong focus and a long time to focus on the features they need to implement. And they want to reduce cognitive load by only focusing on what actually matters. So if you're a backend developer, for instance, you want to focus on the functionality of your service, but you probably don't want to know all the details about how to deploy your service or how to report an incident. Of course, you will have to deal with incidents, you will have to deal with monitoring aspects, but you don't need to know all the implementation details thereof. And last but not least, people are more efficient when they don't context switch too often. And at this level, for developers, we're talking about context switching between emails, Slack, and coding. So an efficient company, a successful one, needs those three levels. You need to produce the right product efficiently. You need to have well-functioning teams that do not depend too much on each other, or at least don't wait for each other. And you need to have efficient developers that are not context switching too much. If you don't have clear product directions at the top level from product leads, what is going to happen is that you might deliver a lot of code, a lot of features, but not the right ones. If you don't have efficient teams, you might end up with teams just waiting for each other and effectively producing no value. And if your developers are not efficient, then the teams themselves won't be able to produce any features. On top of that, people will get frustrated and they might leave. So these three aspects of productivity are important, all of them. We're going to look into it. So this framework is quite important. Data, information, knowledge. When we say we want to be data informed, in fact, we probably mean something else. Let's look into it. At the lowest level, you collect data from systems like Jira, code, deployments, incidents, you name it. You collect this data into databases, typically in a raw form or in a slightly digested so that it's easy to query. On top of that, you can extract metrics, compute them, and produce dashboards so that people can look into them. And from there, you can add additional research, user research typically, and extract insights and make reports out of it. Let's take some examples. In the raw data at the lowest level, you can, for instance, collect all the tickets you have in Jira, or you can collect all incidents. At the metrics level, you're going to be able to look into MTTR, mean time to repair, for instance, from incidents, and produce dashboards. And the insights can be, well, we have realized that this piece of code produces more incidents than the other ones, and therefore we think there's a problem of technical debt. The three aspects are important. Most often, when people say they want to be data informed, they mean metrics informed or insights informed. So from the data we collect, from the interviews we make, from the surveys we run, we can compute different types of metrics. We typically put them into a category such as activity, output, outcome, and impact. What do we mean by that? Activity is going to be about what you do. For instance, the time you spend on a task. The output is what gets produced by you, such as the number of pull requests you submit. The outcome could be, for instance, the number of features that get on the market thanks to your work. And then the impact is the actual impact it has on the customers. We can all agree that what matters at the end of the day is the impact. That's business. But then we will see that we need the other ones as well. It might be worth remembering that those metrics can either be log-based, meaning you take the actual production system you have and you compute the metric from that, or you can just ask people what they think about it, and then you're going to get a perceived metrics. For instance, people can tell you, well, we think we have that many incidents per day, and then the system can tell you how many actual incidents you have per day. One thing to realize is that asking people, surveying people is actually quite cheap, and you can get that data quite fast, and it's reasonably accurate, whereas log data is quite expensive to put in place. It's going to be more accurate, but again, more expensive. The different types of metrics we deal with are actually on a scale. On the left one, more the activity metrics, on the right one, more the business-oriented one, the impact one. And they actually influence each other. But first, let's look into the left one. So the metrics on the left, the typically activity metrics, tend to be a lot more noisy. They change really fast from one day to the next. They also tend to be more actionable. It's easy to take action to change them. They can be used for tactical planning for 1 week, 2 weeks, 3 weeks. Unfortunately, they tend to be gameable. It's quite easy to cheat if you want to change them. There can also be vanity metrics. When I was in charge of CI, for instance, we had the number of builds we were running. Number of builds might be an activity metric. It's not necessarily the most important one. Last but not least, the one on the left, as I mentioned, are more like activity or output kind of metrics. On the right one, you're going to have the business values, the one that actually matters for a company. But they tend to be more stable. It's hard to change the bottom line of a company from one week to the next, obviously. They also tend to be delayed. If you change something on the left and you make a change in a company, that is not going to change the bottom line in the coming 1-2 weeks. That's going to take a while. They can be used for strategic planning, and the type of metrics are typically more like outcome or impact metrics. These metrics are, as I mentioned, in a graph of dependencies. The example I gave here is that if you change build time, for instance, if you reduce the build time for your product, the odds are your developers are going to be more satisfied. As a consequence, maybe they're going to resign less, and the recruitment costs are going to go down. So that's a good thing. And that applies to more or less all the metrics. There is a graph of dependency that you can look into. And in fact, deciding of this graph of dependency is one good way to align the functions in a company and make sure that people understand why we are focusing, for instance, on build time, because maybe in that case, we want to reduce recruitment costs. So we looked into different mental frameworks to address DPE. The first one is what is productivity for different roles in a company. The second one is about the data we collect, the information we compute, and the knowledge we extract. The third one is the different types of metrics we have, like activity, output, outcome, impact, and the fact that we truly care about impact, but we can typically work on activity or output. And then the fact that metrics are in a graph of influence, and that knowing that graph of influence is a way to align the different functions in a company. Now let's look into the use cases, the mistakes we made, the lessons we learned. That's going to be the longest part of that presentation. In the early days of our data-informed journey, we asked every team to be able to make decisions based on data, based on metrics they would collect and compute. So we did. For instance, in the continuous integration team where I was, we started to collect all information about all the builds, and we add that into a database. And then we could compute metrics such as the time it took to build a product, the time it took to recover from a red build to a green build. That was quite efficient, of course. But we had a problem. We could not easily make metrics based on two databases. For instance, it was hard for our team to know which team was affected by incidents in CI because we didn't know which team people belonged to. So we ended up deciding that we would use a common technology, in our case BigQuery, and a common way to store data with what we call taxonomy. That helped a lot with creating metrics that would depend on several datasets. Then we did it the other way around. We created a team, and this team was in charge of collecting data from a lot of different sources. I'm talking about Jira, deployment, CI, code changes, actually hundreds of them. This team created this central database where all the data would be, and that was absolutely fantastic to be able to produce metrics from that. But that caused another problem. The problem is that the company is always evolving. There will be small changes, there will be upgrades in Jira, there will be changes in the way we build, etc., etc. Completely normal. Consequently, the centralized team was always lagging behind. There will be bugs, and the datasets that we created would be wrong sometimes. So instead, what we decided that every local team in charge of Jira in this case, or continuous integration, or other things, would actually be the one in charge of producing what we call the raw data, an extraction on a nightly basis that would make sense. And if they had to upgrade their own systems, they would also have to make sure that the raw extraction would be correct. We started to collect data, we started to compute metrics, produce dashboards, and at some point creating what we call insights, meaning conclusions we take from the metrics. But we didn't quite see initially that we would be wrong actually. The metrics would not be computed perfectly, maybe the data extraction was not so good either, and maybe the insights we took from that were not perfect from day one. In fact, we just realized after a while that data, metrics, and actual insights are product in their own way. meaning that the accuracy and precision will be what it is when you start, but then it's probably initially wrong, or at least not entirely correct, and you need to iterate. You also need to have customers for them, and that's kind of important. If you start to collect data and you produce metrics, but nobody looks at them, that's just a waste of time. You need to make sure there are people interested in what you're producing. As a consequence, as I said, you need to evolve, you need to iterate, you need to make sure customers are interested in your work. And just like any product, you need a vision. You need to know where you want to be in a year from now. What are the metrics you want to expose? Who are going to look at them? What are the insights, the type of research you want to do on your own company that you want to do? You need a strategy to get there. So for instance, if you want to compute DORA metrics, it's actually much harder than people think. Well, which one are you going to take first? Deployment frequency, mean time to recovery from incidents, or some others? So you need a strategy, you need to be transparent about it, and you need to make sure, again, there will be people to look at it. And this is why I mean you need to have a customer relationship. You need to maintain a continuous conversation with management, with the different teams, and maybe with the developers who want to look at your metrics. And that's kind of interesting. You need metadata, metametrics, and meta insights. What do I mean by that? I mean, you want to know who is using your data. You want to know how often people look at your metrics or your dashboards. And you want to know how often people look into your insights. So the way we did that, for instance, was, well, to look at all the queries that were made against the datasets, to look at how often people would open the dashboards, and how often people would refer to insights we produce in our reports. This is kind of important. You need product management, product managers for that. And that's what we did. We did hire a product manager for data, metrics, and insights. So as I mentioned, there are different ways to collect data. One of them is through systems with what we call log data. The other one is through people. Just ask them through surveys, for instance. And for a while, we had a lot of different teams running a lot of different surveys that might look good, but it was actually problematic for different reasons. The first problem we had was survey fatigue, as developers got a lot of questions from a lot of different surveys and they would start skipping them. The second one was about designing the surveys properly. It's actually surprisingly hard to do. The third aspect is the recurrence and the fact that in order to be able to see trends over time, you need to be able to run the same survey many times a few months apart. Then data was not necessarily very easy to get to. I mean, it's not that the database would be closed or anything, but you needed to know where they were. And then if you ask questions such as like, how satisfied are you with your work? Or please tell us more about this thing that doesn't work for you. People will respond honestly if they know that the responses are anonymous. So the solution for us was to centralize that. We would run a quite large quarterly survey on only a third of the company. So that means that people would only respond every 9 months, which is not a lot. Also, of course, this survey would be very well designed, and it was designed to reduce survey fatigue, meaning that, for instance, a lot of questions would not even be asked for the roles that didn't need to answer them. For instance, product managers and developers would actually not have the same question set. And then that would cover the different tasks, what people have to do, such as how satisfied are you with deploying code in production? Or about the tools. How satisfied are you with using tool X, such as Jira, for instance? Then we would ask about satisfaction. How satisfied are you with your work as an iOS developer, for instance? And importantly, there were two types of answers. Likert scale, meaning on a scale from 1 to 5, what do you think of this? And then how satisfied are you, or rather, give us more information in a free text answer, meaning you can write anything you want. One of those things that was truly important here is the transparency on the results. So all the metrics computed based on those survey results, all the free text answers, all the insights we would draw from that would actually be publicly available in the company. That ensured that everyone knew where the problem were and maybe they could help. Of course, because that's a centralized survey, that cannot go into all the details. And the point was to raise awareness and make sure that the local team, which for instance own a given system, say the deployment system, would know there was a problem and they could go even further by themselves doing some user research. So that probably happened to you many times. You open a report and the report contains a lot of charts, but the report does not quite tell you if something is right or wrong and if you should do something about it. That's a problem because that means that the report is not optimized for problem solving, it's optimized for carrying information. At the end of the day, as a company, we want to be focused on solving problems. Here is how to do it. The first thing we want to do is to synchronize the timing. So, we're going to issue a productivity report on a quarterly basis, roughly a month in advance before planning. That gives the team a chance to look into it, decide on what actions to take, and then plan for them during the next quarter. The second thing is optimizing for the investigation workflow when you have problems. What do I mean by that? The first thing is insights first. So insights is not really like a metric. Insights is one level higher, right? It's about, okay, we believe that people in iOS development are unhappy because of the test flakiness or maybe because of build time or some other aspects. This is an insights. And from that, you can bring metrics to support your claim. On top of that, you can enable people to drill down and look into, okay, maybe that's more specifically true for certain type of teams or maybe specific types of repositories. And on top of that, of course, if people need, they can go deep into the data and look for themselves. Now, another aspect is that we really want all the charts to look very much the same so that no one has to spend cognitive load on trying to just interpret what the graph is like. So we want to have a very minimal number of charts with some conventions such as red is bad, green is good, and some other things of the same sort. I wanted to share this particular chart type with you because I think that's a very powerful one for management. This one is based on fake data, by the way. On the x-axis, you got the number of developers working in a given part of the company. And on the y-axis, some productivity metric per developer. If the line was flat, that would mean that if you add another 30% more developers, you're going to expect 30% more deployments. If the line goes upwards, that means that you have a very good manager who is able to leverage all the people to go actually, say, 40% faster if you got 30% more people. Investing in metric has proven hard at times. And there are good reasons for that. The first one maybe is that people discuss which metric to optimize for, let's say test flakiness, for instance, at planning time. And then the cycle starts. And when the cycle starts, then the time you spend on computing the metric is going to compete with the time to actually work on the release. That can be hard, especially if you're late. The third aspect is that it's hard to get it right. Those of you who have implemented DORA metrics know how difficult that is. If you look into, for instance, the time it takes to recover from an incident, that sounds simple, but you need to define what an incident is. You need to check if you actually have a database where the data is, etc., etc. So what can we do about it? The first thing maybe, as I mentioned, is to have a centralized team with a mission. Own the common metrics for everyone and own the common insights. The goal, of course, is to trigger a conversation all over the place in a company. Just realize, hey, we got a problem here. Why don't you look into it? And then, secondly, the management set the tone. We want managers to mention those insights. We want them to mention the metrics, to reuse them. Third, realize that local team will still have to own their own metrics, but they can start simple. They don't need to compute everything from scratch. Maybe they can just ask people, self-reported metrics, and use what we call proxy metrics. Proxy metrics are typically simpler to compute. They don't capture everything, but they're good enough. So we can start with that. Opinions and hypotheses. This is really important to not confuse those two notions. Hypotheses are just a sentence that you can test and prove wrong or prove right. For instance, decrease in build time will increase the number of pull requests per day per developer. Sounds reasonable. But we can design a test for that. For instance, maybe there's a new generation of machines coming up. You can buy some of them, give them to some developers, and see if that increases their velocity or the production of pull requests. That is, run the test. And then you can report validation, invalidation, and potentially the lack of statistical evidence. Most importantly, there is nothing wrong with hypothesis invalidation. It's just statistics. Sometimes you don't even have enough data to prove it right or prove it wrong. Opinions tend to be different. They're typically attached to a person, sometimes a senior person. But what if that is not true? Maybe the junior people won't dare to challenge it. And maybe the company will get stuck because, well, we will believe something that is actually not true. I was myself involved in such a case. I was in charge of the continuous integration environment, and I strongly believe that if we add more machines to the environment, there will be less queue and people will have to wait a shorter time for their builds to happen. I was wrong. But there was no problem with that, because that was just an hypothesis. I was not proven wrong. The hypothesis was. So as I mentioned before, there's a graph of influence of different types of metrics, typically from the activity metrics up to the impact ones. This is important when we want to optimize for, say, deployment frequency, that we go to the different teams and say, okay, what can you do? Which metric can you move in order to influence the deployment frequency at a global level? This is also important to not go to the teams and say, hey, you need to optimize your deployment frequency. And here is why. So let's say you have, say, 10 teams, and you ask all of them, because you want to optimize deployment frequency at the department level, that you want each and every team to optimize for deployment frequency as well. Then you realize that one of the teams happens to help the others quite a lot. And as a consequence, when they help other teams, they don't get the benefit of deploying themselves. So if you push hard on this team to have a higher deployment frequency, what you will effectively do is kill collaboration between the teams. On the other hand, the opposite can happen. In the example I have here, the company had decided to optimize for user satisfaction. And maybe one of the best ways to do that is to fix incidents faster, so optimize for incidents MTTR. If a team is entirely blind to that and only optimize for compute cost, this is completely unrelated to the goal of the company. We need to find the right balance. The teams need to optimize for some metrics that are local, but also relate to the goal of the company. A few years ago, I was walking in the French mountains. I had a map that showed that I could reach a village in a couple of hours. So I walked. Except that after a while, the road simply stopped in the middle of nowhere. There was a mismatch between my map and the actual reality. The same thing can happen to us in software development. Sometimes our metrics, the map, tell us something, but the reality, the territory, is different. And as we often say, if people tell you it's slow, it's probably because it is. Maybe you have a metric that says, well, the builds are really fast, but maybe there's a long queue that you don't measure. So what are the maps? The map is the metrics, maybe the DORA metrics you have implemented, maybe the local metrics that you have for your team, and they're going to tell you something. But it is important to not confuse that with the reality, the territory. Reality is developer satisfaction, user satisfaction maybe of your product. Sometimes you have discussions with teams that tell you that the metrics look very good. This is always very important to also bring user research into the equation so that you can actually look into the territory. Now let's look into a methodology. I have extracted the key points that enable us to be more data, metrics, and insights driven. So the first part is about understanding what gets in the way for faster software development. For that, we're going to collect log data, but also the people's opinion, developer satisfaction survey typically. And we can derive a certain set of metrics from that, such as queues, dependencies, DORA metrics and similar, but also maybe the perception of technical debt, etc. And from that, we can derive a set of insights that we have that, yes, there's a list of blockers that we have in a company, and here's a list of metrics we would like to optimize for. Of course, at the end of the day, what matters is the business metrics, market share, income, or maybe user satisfaction. But of course, we also inherit the metrics coming from the blockers that we have identified in the previous slide. So this is a time when the different functions in a company need to agree and prioritize those metrics together. In this case, we want to both optimize for user satisfaction and the time spent on incidents. Where that becomes interesting is when you can find leading metrics to this that will hopefully help with both user satisfaction and the time spent on incident. In this case, MTTR, that is the mean time to recovery from incident. And we can iterate on that and, for instance, go to the teams and say, okay, maybe find me metrics that's going to help with MTTR. And in this case, the log ingestion delay is probably going to help because that's going to give information earlier to developers to understand what's going on. Then we can plan, for instance, for a quarter, execute, look at results, and validate or invalidate that hypothesis and learn from that. We can iterate then for the next quarter. The key aspect here is the time when the different functions decide that yes, focusing on MTTR is the right thing to do, or maybe on UI response time for user satisfaction. Why is it key? Because this is a common belief that we have between sales, marketing, and other functions in a company that yes, MTTR is the right thing to do at the moment to improve both the business metric user satisfaction and the time spent on incident, which is more like a blocker. I would like to mention a few metrics that have proven very useful to trigger very good discussion in a company. The first one, obviously, are going to be DORA metrics. As you know, they are the mean time to recovery, the lead time to deployment, the percentage of failed deployments, and the deployment frequency. What is interesting is that you can look at these metrics as well at the repository level. So if you think about it, there is a master branch typically where people push their code from pull requests. The time it's going to take to recover from a red build and make it green on master is going to be mean time to recovery. The time it's going to take from the time when you open a pull request until you merge it is going to be the lead time. The percentage of time that you deploy and create a broken build is going to be the percentage of failed deployments. And the deployment frequency is typically how often we can merge pull requests. So DORA metrics have proven very useful at CI level and product level. Then we also have so-called golden technologies, the technologies that we want to see used all over the place in the company, and we're going to measure the percentage of adoption of that. Then we can measure the onboarding time. How long does it take for an average developer to feel onboarded and feel that they can contribute to the code? Then comes the interesting subject of technical debt. It is typically very much impossible to measure technical debt directly, but what we can do is measure the perception thereof. We can ask people, what do you think of this code or that code? And they are usually pretty good at telling you where the code has a problem and where the code is quite good. We can also look at other metrics and try to see if there is a correlation. And for instance, we end up seeing that the age of the code is typically a good predictor of technical debt. Then, of course, we're going to look into self-reported productivity, We just asked people every quarter, how do you feel? Do you feel productive? And with that, we can benchmark ourselves against the other companies. And that creates a lot of value because, well, if you talk to other companies, you learn from them. Now there are threats and risks to take with this approach based on metrics. Let's look into them. Let's talk about the company culture with metrics. It is important to realize that every metric is gameable in some way. If you push really hard for someone to have shorter mean time to recovery from incidents, maybe they will create fake incidents and close them really fast. That's not really what we want. The second thing is that metrics have shortcomings. All of them. They are not perfect, but we can still use them. So for metrics to be really effective, they need to be trusted by everyone. And metrics are here to inform decisions, not to justify decisions that were already made. Last but not least, it's important to come, as I mentioned before, with hypotheses to validate or invalidate, and not with very strong opinions as to what to do. Of course, collecting data, computing metric, extracting insights has a cost. And that can be a problem in some companies. There are running costs. You need to store the data. You need to run processes. There are maintenance costs because things will change. System will evolve. There will be changes in the organization, which will force you to change maybe the definition of some metrics. And then there might be tension between teams as to how to define the metrics. All of that is okay, but you need to take it into account as that might be a threat to continuous operation with data, metrics, and insights. Now I would like to address the problem of being myopic. And by being myopic, I mean looking into the details, looking close, but not looking at the big picture. And that can take different forms. The first one, we discussed that already, is to confuse the map and the territory, meaning confusing all the metrics you have on the organization and the actual life of the organization. Related to that is trusting people's perception. The risk is to discard them and not actually see what's happening. The third one is to realize that the company is a combination of teams that work together. Maybe each and every team is very efficient in itself, but the combination thereof is not. And also related to that, the need usually for platform teams that's going to be here just to help others go faster at delivering software. Thank you very much. I hope this conference was insightful for you. We looked into collecting data, computing metrics, extracting insights, aligning the different functions in a company, and creating a good culture of data informedness. With that, I will leave you with some references, articles, podcasts, which are quite interesting to read. See you soon in Japan.